Welcome. In today's video, we will be learning how to make energy storage and transfer pie charts. There are 5 types of energy: kinetic, elastic, thermal, gravitational potential, and chemical. And you will use all of these when making your pie charts. If you want a more in-depth description of the energy types, I will leave video links in the description. For our first example, you have a wind-up toy which is at rest and fully wound up. This means that all of the toy's energy is stored in elastic energy, which is generally expressed as EEL. To express this, you just draw a pie where the entire thing is elastic energy and label it with that. Now, pie charts get more complicated once you start needing to take energy measurements at multiple points. For example, to express an equation where a toy is wound up and begins to move across a flat surface while accelerating, you would draw multiple pies to express that the energy balance is changing. Your first pie would be entirely elastic energy, because the toy is wound up but not moving. Your second pie would be about half elastic, 2/6 kinetic, and 1/6 thermal. This is because the elastic energy is being used to gain kinetic energy, or speed. And from friction, some heat is being generated. Your last pie would have no elastic energy, and be about 2/3 kinetic energy and 1/3 thermal. It's important to note that at one point, eventually, everything would end up being thermal, but we are not including that. Our last example is more complicated, however. It will really contribute to your understanding of physics. A man is standing on the edge of a 10-meter building with a velocity of 0 meters per second. He jumps off and lands on a trampoline. The trampoline brings him to a momentary stop where he is at ground level with a velocity of 0 meters per second. Then, the trampoline bounces him 5 meters into the air, where his velocity is also 0 meters per second. For this example, your first pie chart would be when the man is on the ledge, and all of the energy would be stored in gravitational potential. Your second pie chart is when the man is on ground level. In this pie, 3/4 would be in elastic energy, because he's pushing down on the trampoline, and the trampoline is ready to push back up on him. And 1/4 of it would be in thermal energy, due to air resistance and the little bit of impact onto the trampoline. Your last pie is when the man is 5 meters in the air with no velocity. Here, he would have half gravitational potential energy, because it's 5 meters and you started at 10 meters. And at 10 meters, your entire system was gravitational potential, so at 5, half of it would be gravitational potential. And half of it would be thermal, due to air resistance and the small collisions. I really hope that you learn more about pie charts and physics today, and there are a lot more informative videos on the way. If you have any further physics-related question, just send me an email at physicshelper7@gmail.com. Thank you.